In previous videos featuring this generator experiment, I used DC motors to drive or rotate a rotor consisting of pairs of magnets around it at high speeds. In the first video, one pair of magnets flew off from the rotor when it hit the nail that was used as a stator for the coils. So I took advice from some of you and made another rotor, but using hot glue to attach the magnets around a wood. But because of the centrifugal force and the weight of the magnets, the hot glue that was elastic due to its rubber-like nature made the magnets to stretch out and hit the stator just like the first one, and the rotor detached from the shaft of the motor. So today, I set out to try making something different. I brought back the setup from previous videos, but I did a lot of things differently. So let's make the generator. I started by getting this little block of wood, the same one I used previously, and I got an aluminum shaft and passed it through the hole in the wood and used super glue to hold them together. You will see in a bit why I extended one side of the shaft from the wood more than the other. I then got a wood as always for the base and two PVC pieces that I heated flat, which has holes on them for where the rotor shaft will pass through to allow the PVC pieces to lift the rotor off from the base. I noticed from experience that the flat PVC support pillars, that's what I call them, would shake violently while the rotor rotates. So I then got a square shaped PVC to act as a support for the pillars and cut diagonally across it. But first, I glued the support pillars down to the base, changed my camera angle and applied super glue on the pillars, and then got these triangular pieces from the square piece that I cut diagonally to support the pillars and make them more rigid to help cancel out any unwanted motion during rotation. I placed the second triangular support at the back of the other support pillar and of course used super glue to keep them all together in their assigned positions. I then got these same magnets that I used in previous videos, and instead of using hot glue, I used super glue to attach the magnets to the wooden rotor. I glued two magnets each on all four sides of the rotor and applied a lot of super glue to keep them steady. Now, one of you guys commented that I should use hot glue, made a point that it would allow me to remove the magnets anytime without damaging the magnets, but I'm doing this for science, so you better like and subscribe. I put the magnets around the wooden rotor in north-south orientation. If you like videos and experiments like this using wires and magnets to generate your own electricity, then feel free to like and subscribe. That's your own way of supporting the channel. Now that the rotor is done, I got the same stator that I've used in the previous videos, and I think it's about 1,000 tons, and I've forgotten the size of the wire. And yes, I used a drill to make it easier. So I got the base that already has the rotor attached on it to mount the stator, and found out that it is not on the same level or height with the rotor. So I got 4 flat PVC pieces. I used super glue to hold them on the base to make the rotor lifted and also match the height of the rotor. I then stacked each piece onto another and used super glue to hold them. I then attached the rotor to the pieces and glued them on the board and kept the rotor as close as possible to the stator. After doing all this, the generator is set and ready for testing. There was a noticeable pull as the magnets tried to pull in the stator towards itself, but regardless, I got a multimeter to test the output of the generator. Since this is an AC generator, I flipped the dial of the multimeter to the AC section of the multimeter and then connected the leads of the multimeter to the terminals of the generator. I then spun the rotor by hand and got around 3 volts, which is good enough. The first multimeter had some of its pixels missing, probably from all the splashes that it has received from previous videos about hydro generators. Do take them out, they are very interesting. Now, spinning the rotor again, we can see from the new multimeter that I brought that the AC generator could get up to 4 volts just from spinning it by hand. Now, let's do some real tests. I got a drill and attached it to the side of the rotor with a longer shaft. Now, I made the shaft to be extended like that and off the edge of the base to allow me add accessories like this drill and maybe a turbine in the future for other experiments. The generator started with around 40 something voltage, which was weird considering that the last ones I used the DC motor on gave just around the field of 17 and 14 volts. Turns out that the dial was in between the 750 and the 200 voltage ratings of the stator. So I corrected that mistake and tried again to see that the generator gets up to 14 volts at around full speed of the drill. And now again, one of the pairs of magnets flew off of the rotor and landed just around the area. Anyway, that is it for today. Now, if you like videos like this, don't forget to like and subscribe. Turn on your notifications to know when the next one drops. But until then, don't just build, bend the rules while doing so. Make some noise, make some mess before you make some sense. I'm Emmanuel and you just watched Nexel Labs. So thanks for watching. I'll see you around.